Welcome to Study Loop.
Okay, we have this triangle. I'm going to draw it down here. Oh, that's not a triangle. Okay, here we go. And let's say this side is A and this side is B, and then theta is in between them. Okay, in the first question, part A and B are fixed. They are 2 and 3, and they are not getting any bigger. And d theta dt, or theta, is changing. The rate that theta changes is 0.2 radians per minute. So since it's a rate, its name is d theta dt. Okay, so this would be C right here. And then A was 2 and B was 3. Okay, now theta is getting bigger. Okay, so in a little while it's this big. And then in another little while it's this big. And then in another little while it's this big. But A and B are staying the same length. But you can see that the area is changing. Okay, so the question is, how fast is the area changing? Okay, so we have A equals 1/2 AB sine theta. And A was 2, B was 3, and d theta dt was 0.2. Okay, so A and B are fixed. They're not going to change. So let's put them in before we take the derivative. 1/2 times 2 times 3 times the sine of theta. So A is 3 sine theta. Okay, now the two things that are changing here are theta and A. So when we take their derivatives, they get a dt stuck on it. So here we go. Derivative of A, dA dt. Derivative of 3 sine theta is 3 cosine theta times the derivative of theta, which is d theta dt. I think I missed something here. Also, find dA dt when theta is pi over 3. Find dA dt. Okay, so it's not saying that theta is pi over 3 all the time. It says at one of these instances over here, theta is pi over 3, and at that instant, how fast is the area changing? Okay, so just plug them in. 3 times the cosine of pi over 3 times d theta dt, which was 0.2. Pi over 3, that's 60 degrees. That square root of 3, 2, 1. So the cosine is 1/2. So 3 times 1/2 times 2. So 3 what? Well, A and B are centimeters, so it's centimeters squared. And d theta dt was in radians per minute, so it's centimeters squared per minute. Okay, now in the next one, B is changing and theta is changing. So the rate that B is changing is called dB dt, and the rate that theta is changing is called d theta dt, but A is fixed this time. Okay, so here's the picture. Okay, A is 2, and then here's B, and here's theta. So here's our other side. All right, so theta is getting bigger. Oops. Theta is getting bigger. See it getting bigger? At the same time, B is getting bigger. So now we have this. And then theta gets even bigger, and B gets even bigger. And now we have this. And then theta gets even bigger, and B gets even bigger. And now we have this. Okay, so two things are changing this time, B and theta. So A is fixed at 2. B is changing at a rate of, I forgot, 1.5 centimeters per minute. And theta is changing at a rate of 0.2 radians per minute. And so we're trying to find not d theta, dA dt, the rate the area is changing when B is 3 and theta is pi over 3. equals 3. Theta is pi over 3. So it's like this is happening, and we take its picture right at the instant when b is 3 and theta is pi over 3. What's the rate? The area is changing right there. Okay, same formula. A equals 1/2 AB sine theta. We can plug in A equals 2, but we can't plug in B equals 3 because B is changing. So you can't put anything in below this line until after you take the derivative. Okay, so right before you say find, you can't plug any of that other stuff in, but we can plug the 2 in before we start. So we get 1/2 times 2 times B times sine theta. So that's B sine theta. Okay, now this time 3 things were changing. Remember, B is changing, theta is changing, and the area is changing. So over here on the right, we're gonna have to use the product rule. All right, so here we go. The derivative of A, which is dA dt, equals the first, B, times the derivative of the second, which is cosine theta, times the derivative of theta, plus the second, which is sine theta, times the derivative of the first, which is dB dt. Okay, the first, B, derivative of the second, cosine theta d theta dt, plus the second, sine theta, times the derivative of the first, dB dt. Okay, so now just plug stuff in. So B is 3, theta is pi over 3, d theta dt is 0.2, theta is pi over 3, and dB dt was 1.5. Pi over 3, remember, 60 degrees, square root of 3, 2, 1. So here we get 3 times 2 times the cosine, which is 1/2. Plus over here we get 1.5 times the sine, which is the square root of 3 over 2. So it's 3 plus 0.75 times the square root of 3. I don't know where my calculator is, which is something, and again, centimeters squared per minute, because it's area changing. All right, now in the third one, A is changing, B is changing, theta is changing. So they're all getting bigger, and they just keep getting bigger, and then let's find dA dt. All right. So we have dA dt was something, dB dt was something, d theta dt was something, and we want to find dA dt when they have to tell us what A is, what B is, and what theta is. Okay, remember, nothing below this line can go into the equation until after you take the derivative. So dA dt was 1.5, 1.5, 0.2. Okay, 1.5, 1.5, 2, and I bet this is 2, 3, and pi over 3. Yeah. Okay, so big A is 1/2 AB sine theta. Okay, this time we have 4 things changing. Oops, sorry. A is changing, B is changing, theta is changing, therefore the area is changing. So when we take the derivative over here on the right-hand side, we got 3 pieces. So we're going to have to do a fancy product rule. So let me show you an easy way. If y is the function f(g)(h), so 3 functions, its derivative is take the derivative of f times gh plus take the derivative of g times fh plus the derivative of h times the other 2. So the derivative of each one times the other 2. That way we don't have to do anything fancy. All right, here we go. dA dt equals, okay, the 1/2 is just going to be out in the front there. Okay, the derivative of the first thing, that's dA dt, times the other 2, plus the derivative of the middle thing, that's dB dt, times the other 2, plus the derivative of the third thing, which is cosine theta d theta dt, times the other two things. Okay, and this rule will work if you have 4 things or 5 things or 6 things. You take the derivative of one times the other ones, plus the derivative of the next one times the other one. So you never have to use the product rule more than once. All right, now all we got to do is plug some stuff in. Okay, we got 1.5 times 3 times the sine of theta, which remember was square root of 3 over 2, plus 1.5 times 2 times the square root of 3 over 2, plus the cosine, which is 1/2, times 0.2 times 2 times 3. All right, let's see if I can do this without a calculator. No. No. Okay, so just calculate all of this and then put it in your calculator and calculate, and out will come the answer. I can set it up a little bit more. 3 times 1.5, that's 4.5. Divide by 2, that's 2.25 square root of 3. Plus this one is 1.5 square root of 3. Plus this one is, those cancel. 3 times 0.2, so 0.6. So 1/2 of 3.75 times the square root of 3 plus 0.6. So add those together, divide by 2, and that will be dA dt. Again, centimeters squared per minute. Hope that helps.